like the C statement or Java statements. Here in the programming language, in assembly language, we also have statements, and we know that we have three types of statements. Can you remember the names?
Executable instruction, assembler directives, macros.
And
assembler directives.
Exactly, assembler directives, and the last one,
macros.
Macros, correct. So these are the three types of statement we have in assembly language. So in executable instruction, what is executable instruction? Anyone? The statement which can execute, right? So that is the executable instruction, and in this executable instruction, we have operation code. In short, what is the short form of operation code?
Opcode.
Opcode, yes, correct. So opcode is, we are using opcode to write the code, and then we also know that the executable instruction is converted into machine language. Okay, so that is the executable instruction. However, the assembler directives, which is non-executable because they don't execute directly by the processor. So and also doesn't have any machine language instruction. So why we need the assembler directives? Can you remember that why we need them? If it is not executable and if it is not executed by the processor, then why we need them? Assembler directives is like information or the definition of the executable instruction. Most of the time is assembler directives. These are you have to define some data, you have to allocate some memory, right? You have to allocate some array or table or create a table. So those kind of things you are going to do by these assembler directives. Fine, so it will help you. These assembler directives will help you to run the executable code. It will give you the space and environment to execute the executable instruction. That's why we need them. Fine. And the third part we have discussed that macros. It is very similar to what in our high-level language. Which one? Macros. Similar to. Come on, anyone? Can you remember? The macros in assembly language is very similar to what? Yesterday I have told you. Similar to our function. Similar to our function in C language or the high-level language. So whenever we write function, we just need to call by name. And whenever you call the function, the whole code related to that function will execute. Right? We don't need to write those functions again because it's already written. You just need to call the name. Similar as here, macros meaning a collection or the group of statement. If you want to use them, you just call by name, and then all of the code or all of the statements of these macros will be executed. You can see that it says during the assembly process, each macro is represented by the group of statements that is represents an assembled in place. The process is referred to as macro expansion. Right? And I think I told you that you should read it from the book because the book has a very nice description. Similar description, but they have written in a nice way. This one. Okay. Yes, Mr. Mohanur Rahman.
Sir, you said I was actually looking through the assembly language statements, not statements, the assembly language code. So how it is get written or how it is used. So doesn't assembly language doesn't have any emulator to run the code or anything?
Does assembly language what?
Does assembly language has any kind of emulator or like code?
No. You actually need to write it on your processor. There are some specific way. There are some specific environment and software by which you can write directly to the code, directly to the processor. For example, your BIOS. BIOS is a special types of software and special types of arrangement, right? It's not like our normal daily life use. Similar to our BIOS. Or another example is whenever you write code in a Arduino Uno microcontroller or Arduino microcontroller, you need to use a very specific software, right, to write some very specific code.
Yes, sir.
So those kind of environments you have. This is the best example you use every day. That's why I give this two example, because some of the other systems, they have some of the other way or environment to write the code directly to the machine or directly to the processor. Just think about your BIOS. It's a special kind of software by which you can change into the hardware level, right? So there's the same thing.
Okay,
if you have let's say, for example, you have an embedded system. Let's say you have an embedded system for the television, all right? Or you make a robot with an embedded system. So there must be some other process. If you use Arduino, you use the Arduino software to write the code. If you use the Raspberry Pi, you use the Raspberry Pi software to write the code. So if you use any other microcontroller, you need to write the code for their own environment. So different environments, different way you need to write the code. Fine?
Okay, I understand.
Okay, so we are, after that we have discussed, with one more thing, and types of, or the statements, we also have discussed about the general format to write code. So this is a general format, and we know that all of the coding are not same, so that's why there are some optional parts. So we can see that the third bracket one, like this one, and this one, they are optional. Okay, and this is actually our output. It's called mnemonic. So this is our opcode or operation code, and the rest of the part, these are optional. Not always optional, but some of the cases they are optional. So we have levels, our opcode, operator name, and comments. Okay, let us see some example. They have given example this one. If you compare this general format and this example, you will understand very easily that this is the level. We know that after the level, we must have one semicolon. And then this is a mnemonic, that this is our opcode. Operand means the variable, and this is our comments, whatever we write. Very simple. This is another example we also have to write an assembly language statement. After that, we have discussed about the data allocation. We know that the data allocation is the best, not best, I mean, first step to write the code, because we need to declare our variables. So this data allocation part, or the declaring the variable parts in assembly language, it is called define assembler directives, or just in short, define directives. Okay, so define directives or define assembler directives. So in this define directives or define assembler directives, we will define some of the variable we are going to use in our code, which is the first step to write any language. Same as here as well. So there is a common format. This is the common format by which you can declare our variables. You can see that there are also some optional part. Okay, so we have variable name. So you must thinking that how come variable name is the optional. Some of the cases is optional, not all the cases. Some of the cases is optional. Then we have define directives. We have already discussed. This is define directive means types of the data. So yesterday, if you remember, there are 5 types of data we have discussed. These are these 5 types. Then initial value, you need to give at least one value. That is mandatory. But the other values is not mandatory. That means second, third, fourth, not mandatory. But first one, you must give this. Okay, so that is our general format to write or to define a data or a variable. Let us see some example. This is the example. This is the example how we can write or define any variable. If you compare this one, with the general formats of variable name, we have variable name which is sorted. Define directives, we assume that this is db, so we have defined as db, and then the initial value is y. So in bracket comma, that means it's a character. All right, so that's the way we can declare any variable. And we also discussed yesterday these 5 different types of defined directives. That means these are the 5 different types of data, or this is the 5 different way we can store the data, whatever the way you understood. So this is the 5 types. We know that the first D means define, and the next character is actually either it's a byte, word, double word, quad word, and 10 bytes. We remember that byte means, of course, 1 byte. Word means always 2 byte. Double word means 2 words. 2 words means 2 multiplied by 2, 4 bytes. Quad means 4. Word means 2 bytes, so 4 multiplied by 2, 8, and 10 bytes is 10 bytes. And we need to remember this one. We need to remember another thing, which is the range. Where is it? The range, this one. The numeric, the range, that means if you want to store a value in any specific types of the data, you must follow this, because these are the barrier. These are the minimum and maximum number you can store. Otherwise, if you do it otherwise, then you might have different values. Okay, if your number is very small, but you're using the larger one, no problem. Technically, no problem, but you actually wasting the memory location, which is very, very not, good idea to do it. But if you do the otherwise, that means you have a larger number, but you store it in the smaller space. That means you must have the wrong number. Wrong result. All right, so we need to remember this one, and it's very similar to our C programming code. We know that whenever you define the C programming code, this is the C. It is very well known and common that we write in the C in this way. So each of the value, they have the range. So similar way, our defined directives also have some range. This is the byte-wise range. This is the value-wise range. Okay. Any questions so far? Okay, if there is no question, yesterday we also have discussed one more thing. Just give me a moment. Okay. Yesterday we also I have shown you that that one statement can be written in 3 different ways. Either you write it in this way, which is denoted as a character. Then we can write the same code by this way, which is a hexadecimal number, or in a binary number. All of these 3, same thing, representing the same code. So we can write it in 3 different ways, no problem with that. We have also discussed yesterday that, if you still can remember, that our Pentium processor, because we are talking about Pentium processor, our Pentium processor is using the little ending byte ordering. That means what is little ending byte ordering is, that means it's storing the data for the least significant bit first, and then the most significant bits. For example, let's say we define this value. Value is our variable name. DW, that means double word, that means we have 2 bytes, and this is a decimal number, 25,159. So that is the way you have defined the variable called value. So after you define it, the processor and the accurate convert this value into the equivalent hexadecimal number. This one. All right, H means hexadecimal number. Hexadecimal number, and then it will store into the 2 location or 2 bytes memory location. We know that the least significant bits like 4 and 7 will store into the first byte. So X means first position. All right, and then the next position, that's why it's X plus 1 is next position memory location. Remember, is stored is 6 and 2. Another example, another variable, same to is a negative number. So if you convert the negative number, you can have this hexadecimal number. Same way, the least significant bits like B and 9 should be in the first byte, and the B, 8 and D is in the second byte. Larger example, total variable. This is a variable. DD means double word, right? Double word means 2 multiplied by 2, 4 bytes. So we have 4 different places or bytes we have in the memory. And because we have a larger number, decimal number, very big number. Can anyone tell me what is the number, how we can pronounce this number? This is a decimal number. Not, okay.
Do we have to, sir, convert it in binary, sir?
No, I'm asking, not is an assembly language question. I'm asking how we are going to write this in a word, or say it in a word. This number, this is a decimal number.
542803535.
Yes, okay, but if you write in like thousands, hundreds, then.
Sir, can I?
Yeah, try.
Sir, 5,428,003,535.
Little bit wrong.
Sir, 54 crore, 28 lakhs, 3,535.
Okay. Crore and lakh is fine, but if you think about the millions, that's what I'm trying to say that.
Okay, so 542 million.
Correct.
And 80 lakh and 3,000. Sorry.
Million.
Yeah, 8 million and 3,535.
No, again, try again.
542 million.
803,000.
Oh yes, 803,000 and 535. Yeah.
Simple. It is always better you know the way to pronounce or to in a number in a million and billion way, because it's a global way. Lakh and crore is not actually the worldwide accepted. So we should know about the million and billion, how you can write it. So it's very simple. You just take 3 by 3, like 3 word, 3 and 3 and 3. So the first 3 is the 100, second 3 is the 1,000, and then the million, and then the billion, and then the trillion. After trillion, what is the name of the trillion? Pentillion or something like that. Anyway, very big number, 10 trillion or something. So it's better you actually know this one. I know you know it, but still just asking. Anyway, it's not related to assembly language. I'm just asking. Okay, so if you define this number as a very big number, we know that. So obviously the DW and DB cannot store this one. So you have to use the double word 8. That means 4 bytes. So if you convert it into the hexadecimal number, that is the hexadecimal number. It's just an example. I'm not saying that you have to do just an example, a bigger example. So this is the hexadecimal number. Very simple. We have 4 bytes. So obviously the least significant will store first. That means 4F will store first in the first place or the first byte. Second byte 86, third byte 5A, and the last one is the 20. That's why they have stored the data into the memory serially. The good news is generally, I mean not good news for you, for the computer, is whenever you write an assembly language, whenever you define any data or define anything serially, then the assembler allocates all the data in serially into the memory, not like one is here, one is there. You actually put it in serially. That is the best thing of the assembly language. That's why it's also giving a very fast response. Okay, fine. All right, we have some uninitialized data. It is called uninitialized data. So it is a very special one, which is called the reserve. Reserve word, some of the reserve word, for example, RES, of course, same thing, right? RES, that means reserve. B means byte, W means word, double word, 10 byte, simple. Just extra RES, that is the reserve. Okay, so whenever you don't want to initialize the specific way like this way, if you want to do some in reserve word, then you can do in this way. Okay. And there are some other specifications also. For example, each of the reserved directives takes a single occurrence that specifies the number unit space. So it's a very special one. But generally in this course, we are not going to use this any kind of reserved byte word or anything else. So generally we use these 5 directives, not this one, just for your knowledge, that we have some reserved one. Now let us see that how we can do multiple one. Previously, we have just done the single one. They like define this one, single. We can do also the multiple way. It's called multiple definition. All right, so the multiple definition is you can write several times way. You can write a message like this way. Let's say you want to store a string, so you can write like this way: message, each of the character, or message, comma, each of the character, or message, inverted comma, everything together. So there are 3 ways you can do multiple definition. All right. You might think that 1 DB can store 1 byte of code or 1 byte of data. That means 1 character. So how come you have just written 1? Right? The answer is, you can see this one doesn't have any problem because they have written separately. That means in the DB we have 1, 2, 3, 4, 5, 6, 7, 8. That means we have 8 bytes. It will be allocated message variable in this case. Here we also have the same because we are writing it within the invite comma with the comma. So the same way, 8 byte will be allocated for message. Same way as here as well. Message also can be stored like this 8 byte, not 1 byte. But each of the characters is actually using 1 byte. Same as here as well. It is with inverted comma, and that is without inverted comma, but with the comma. So we can do in this way as well. If you want to think about the numbers, it is also can be like in this way. It is very similar to our like array. Right? It's not a single one. It's very similar to the way we define the array. Although there are other ways to define the array, but this is one kind of way we can define an array like individually. Okay. So these are this is only the characters. The example, this is only the character. This is the characters. This is the example of character and numbers together because 0DH means this is an hexadecimal number. 0D, 0AH means 0A hexadecimal number. So this is a combination of number and character. And this example is actually totally numbers. So it's kind of an array because each of the position of the array, we are storing some of the data, and each of the data has their initial values. So this is the variable. This is the type of the data of that specific position, and that is the initial value. That means in 0 position, we have, let's say, for example, in 0 position of this message, this is an array. We have B, first position, Y, second position, E, and then 0D, and then 0A, like that. So it's a kind of an array because multiple definition is always array, right? So array or string. So here we have just given 3 different types of example that how we can define multiple, we can call it array. Either is all of them are character mixed of character and numbers, and then only the numbers. So that is the possible combination we have. Fine. There is some problem here. So if, for example, you want to store like 100 or 200 data, in that case, you have to write it 100 times or 200 times? Not really. There are some way we can do it simply, which is this. Generally, we use this one. We are going to use this one. Generally, we are not going to use this comma thing. If you have very small one, then it's fine. But if it is not, if it's a larger number, then we use generally this one. All right. It is called the times. So this is the way we are going to define an array or table. So this is, let's, for example, this is an example. So what does the mean of this example is variable name. You have to write the times, T-I-M-E-S, time. This is the keyword. The way you have to write is the same way. Times, how many values we have in this variable, in this variable, 8. Which of the, what is the type of each of the variable of these 8 values here? In this case, it is DW. And what is the initial value of each of these 8 values, which is 0 in this case? Fine. Let me tell you again how we are going to define an array. Variable name, the word times, you have to write times. How many components it should be inside this variable? What are the types of each of these variable? And what is the initial value of each of these variable, or each of this space of this variable? That is this, the last one. Fine, so that is the way we can, no need to write the same long code. Instead of that, we can easily write this. Fine. Variable name times how many component or elements you want, what are the types, and then the initial value. That is the way we can write. Any questions so far?
Sir, why is times after 8, sir? I didn't.
8 means how many elements you have here. This is an array. Remember, in the C programming, in the third bracket, you have to write a value.
Yes, sir.
This one, this is that value.
Okay.
Any other question? I missed one thing, that you also can write, although we don't use this one, we also define a value like this way as well, like a little bit of arithmetic one. So if you want to define in this way, you can also define in that way also, same thing. Although we don't use it, and if it is necessary, it is possible, but it is still, still most of the time we just use this one. But it is possible that we can write or define a value like in this way. I also missed one topic, which is in this one. Let me ask you, do you have any question before we explain this one? No? Good? Fine? Okay, this one, which is actually saying, what is actually saying that I just told you previously that assembly language, in assembly language, or the assembler allocate the memory location one by one. Right? It is a continuous one by one. It's not like one is there, here and there. Not like that. It's a continuous one. That's why she states that when the several data definition statements are used as above, like this, the assembler allocates continuous memory for these values. All right? Let's say, for example, you write these 3 lines. So let us see what are these. So there is one variable, which is db type. This is just a value y. Okay, just one character. Second one value, and this is the variable name, dw type, that is 2 byte, and this is decimal value. Third one is a total double word type, and this is the value. So let's say just mention these 3 lines. So whenever you mention these 3 lines, whenever you define these 3 variables, what actually the assembler will do is calculate from here and allocate all of them in a serially in the memory location or memory segment. For example, for the first one, we have just one byte. So the first byte will be Y. Okay, they have written the corresponding hexadecimal numbers. So that's why we have written 799. So this is the hexadecimal number of Y. So in the first byte, we have this value. After that, we have 2 bytes of the data. So the second and third position will be, if you convert this value, if you convert this decimal number into the hexadecimal, this is the hexadecimal. So 4, we know that we are going to store it into the least significant bit first. So 4 and 7 will be in this place, and 6 and 2 will be in this place. And we can see that this this first position is for the sort variable. Second and third position is for the value variable, right? So for the 1, 2, 3, fourth positions, from starting the total variable is actually starting from the fourth position or the fourth place of the memory. So we know that it is a double word. Double word means 2 multiplied by 2, 4 bytes. So there are 4 bytes, 1, 2, 3, 4. So starting from the least significant bit and ending with the most significant bit, which is 20. So that's how the main reason is we are going to use this characteristics or feature in the next topic. That's why we need to know this. That means whenever we write a code or define data in this way, the assembler which converts the data from assembly language into the machine language instruction. So the assembler allocates the memory serially. It is called contiguous. Contiguous means serially, one by one. In this way, let's say, for example, if you want to find, let's say, for example, the processor wants to find out the value, the memory location of the value variable. So obviously, it knows that, okay, it has, by the way, we are going to show this, there is a value to find out the value, to find out the position, memory location of this value variable, which is started from the second position. So it goes to directly to this position and can find the value instead of looking for all the values in the memory location. It is easy for you to understand the next topic, which is called symbol table. It is called symbol table. That means what is symbol table? That means this is a symbol table. So what is a symbol table? Symbol table is whenever you define a group of data or variable, the processor is actually making or maintaining a table. It's like an index of a book. It's like the variable name. This is the variable name in one column. Another column is the offset value. We are going to see what is offset value. Offset value. Okay. Very, very similar to the index of any book. If you go to the index of your book, which you actually found 2 information, right? Topic name on the left side and the page number on the right side, right? So if you want to find any specific topic, you just go directly to that page. For example, you want to find out the chapter number 4. Obviously, you want to, let's say, for example, in the 4.3, you want to find out. So in the index, it is written that it is in 74th page. So you go directly to 74th page and then can find easily 4.3. Indexing, right? Similar way, the processor also does the same. Whenever you are writing a code like this in assembly language, right, the assembler asks the processor to do, because these are not executable instructions, these are defined directives. All right, so this gives you an idea, gives the instruction to the processor that how you're going to use them. So after having this declaration, the processor makes this table, which is called symbol table. So in this symbol table, we have the variable name and the offset value so that the processor can find that any specific value very easily by using this offset value. Just as I said, offset value is nothing just like page number. You have a very large memory location. If you know the offset number, you can easily find the value. Okay, so let's see what is the offset number. Offset number is, let's go back to the previous example, this one. If I ask you that I want to find out the value or the variable of total, what is the memory location? So you should say that it is 1, 2, 3, 4th location, right? But memory is starting from 0, so you should say that, okay, 0, 1, 0, 1, 2, 3, 0, 3. So third of the position, you have this value. So I can easily go to that. Okay, so I know that this first 3 is occupied by the others, so we'll go for the after 3. So this is the value. Fine. So that is actually the offset value. So let us see how we can calculate the offset value. This is an example. Let's consider we have defined value, sum, marks, message, and child or character 1. Let's say character 1. Okay, so we have 5 different types of variable we have declared. Now we are going to find out, now the processor is going to define the offset value. So the first column is not a problem, then just the name of the variable name, and then let's find out the offset. Obviously, when this, we know that for this portion, we're starting from the 0th position, right? I told you that the 0th position that we started from. Always the array will start from the 0th position. We know that. So let us consider that whenever we have this one, we started from the 0th position of the array. So obviously, the offset position will be 0 for this variable because it's starting from 0. How many bytes we have here?
2.
2, right?
Yes, sir.
So 0 and 1 are the first. 0 and first position will be occupied by the variable value, right?
Yes, sir.
0 and first position will be occupied by the variable value. So whenever you try to store another variable, in this case, it is called sum, what will be the position? 3rd position, right?
Yes, sir.
Because it is continuous. So we know that it is starting from 0. That's why what will be the position of the first position of the sum? 2, right?
Yes, sir.
2. Similar way, because this is very simple. This is 2 words. This is word, so that is 2 variable. Obviously, the next variable will start from the 2 next position. So look at it. So sum. What is the size of this sum?
4 byte.
4 byte.
4, right? Why it is 4? Because it's double word, and each of the word is 2 bytes. So 2 multiplied by 2, that is 4. So double word means 4 bytes. So obviously, if you just add this 4 with the previous 2, it will be always 6. So the marks variable actually started from 6th position. If you started from 0, right? And then the same way, for example, this one. Message, oh, not this one, sorry, 3rd one. Marks times n TW 0. What does it mean? Marks is a variable, is an array because it's times. How many components we have?
10, sir.
10. And each of the components is 1 byte. How many bytes?
It's a 2 byte.
2 bytes. So altogether, how many bytes this marks variable occupied?
20.
20.
20 bytes, right? 20 bytes. So the marks variable occupied 20 bytes. So if you just add this one with the previous one, so it should be 26. That's why, look, the marks is starting from the 6th position and ended in 25th. That means the next variable, which is the message, is starting from 26th, right? 26th. Now let us see when the character 1 will start. Let us see. So this is a message. DB means 1 byte. How many characters we have? Including 0 and including space. Count it. Remember, we have this number of characters, including everything inside this semicolon. including this, including this invited comma, including the space and everything, comma, another 0, extra 0. How many?
14.
14, right?
Yes, sir.
We have 14. So if you count them, all the characters, including the space, this will be the 13, and this is 1, 0. This another one is 14. So this message variable is actually occupied 14 byte of memory location. So if you just add with the previous one, which is 26, you have 40. That means the next variable, character 1, this will start from the 14th position in the memory location. Is that clear?
Yes, sir.
So
no,
this,
sir. The grade is 14. I didn't understand that thing.
look, count like how many, whenever you have invited comma, everything you have to count as a character. How many characters we have? 1, 2, 3, the space 4, 5.
Oh, okay, sir. Yes, sir. Now I understand.
Okay. So altogether, you must have 13 characters, including the space and this colon 13, and you have comma 0. That means another one. Altogether,
Yes.
14. So we have
Yes.
26 plus 14 is 14. So if I give you some code, I hope you can make this offset table, right? I mean, not offset table, I'm symbol table. You can do that, right?
Yes, sir.
Yes,
Yes,
sir.
sir.
This is a very common question. This is a very common question in the midterm that I give you one set of code. You have to calculate, you have to find this symbol table. All right, and this is also the way that the processor or the assembler define all this data, allocate the memory location, and give the instruction to the processor that, okay, this is my table, this is the way I have arranged all this information. Whatever you need, just check this table and then use it. And then the processor use this table to access all the data in from the memory. That's why it is faster. Fine? Hopefully you understand. Let me give you the attendance part because I think you get bored. Then we will discuss the rest of the part. Although we don't have that much, but let me give you the attendance first. I will post one more thing, which is a very short survey about the feelings or the feedback of this course so far. This will be anonymous. That means you don't need to write your name, ID, or email address, nothing. You just need to give the feedback. So I suggest you and request you, please give us a very honest feedback about the course you're having right now. So that will, as I said, that will be anonymous. So I never your name and something, but I always prefer that you should give us true, honest comments so that we can improve ourselves, because you know that everything is not fixed. It should be always, we should always update ourselves. The faculty, the department, the university, everything. So your feedback is really valuable. So please give us a very honest feedback. No need to try to impress me. No need to try to criticize me if you don't like me. You can criticize, but honest criticize. So the intention should be not to criticize me, all right? I know you don't like me, but still you should criticize in a way so that we can improve ourselves, so we can offer better course or better services to you. That is the main intention, right? Because you know that we are changing our course curriculum, and this course will not be added in the next semester, next year, actually, not next semester, next year. Himel Shokar. Shahriar Haq.
Yes, sir.
Fazimul Haq Ronnie.
Present, sir.
It Hassan.